Hello guys and welcome back to the STL series. Till now we have talked about vectors, stacks, queues and sets, and today we will be talking about maps and unordered maps. So what are maps? Maps are associative containers which store values in a mapped fashion, which simply put means that it stores values in key value pairs. Now these key value pairs can either be of a predefined data type or a user defined data types. The thing to remember here is that no two values can have the same keys, that is, duplicate keys are not allowed. So with this introduction, let's get to coding. Now the declaration of maps goes something like this. We write map followed by the data type of the key and the value. Here we are making map which represents square numbers. So we will have a key which is an integer and its value which would be square number of the integer. So here a key and value will both be integers. So now let's insert values into our map here. So to insert our values, we again write the map name dot insert, which is a built-in function in which we will be passing a pair of the same type as that of the map, and here we will give the key and the value. So this would insert the key 1 and value 1 into our map. So let's insert more values into our map. Now to check if we have inserted the values properly or not, we would be using a for loop which would go from square.begin, which would be this address of this, to square.end, which would be the address after this. So this simple for loop will loop through all the values and simply print it. Running it, we can see that all our values are displaying properly. Now the next function that we will be talking about is size, which gives us the number of elements stored in the map. So for that, all we need to do is the map name dot size. And here we can see that it gives the size of the map. And the next function would be something called max size. Now the difference between size and max size is that size gives us the number of elements stored in the map, whereas max size gives us the capacity of the map, that is the capacity that the map can hold. And here we can see that currently the map holds 8 elements, whereas it can hold these many elements. Now the next function is empty, which tells us if a map is empty or not. If the value returned is 0, it means that the map is not empty, and if the value returned is 1, then the map is empty. So we can see here that the value returned is 0 because we have inserted these values. Now we can cross check this by commenting this out so that we just have a map without any inserted values and rerun it. Now we can see that we have a size of 0 and empty returning 1. Now we'll bring this back to life, and after that another function, erase, which lets you delete values from the map. Okay, so now the changes I've made is that I'm printing the map 2 times, and now this would be our original map, and to delete an element, all we do is square dot erase, and in the parenthesis we give the key of the element that you want to delete. Suppose I want to delete these elements 5,25, all I give here is 5, and then run it. Now we can see here that our original array map is this and final map is this, and 5 is not in the changed map. Apart from that, we have another function called clear, which clears the whole map, so you basically start with nothing in the map. So here you can see original map and the changed map has nothing in it. This is all about maps. Now let's talk about unordered maps. Now unordered maps again are associative containers which store values in a key value pair. So how is it different from a map? The answer is that an unordered map stores values with help of a hashing function. So what the unordered map does is that it takes the key, hashes it, and then stores the both key and the value at the index of the hashed value. So we can take the help of this example here. Lisa Smith is the key which is hashed and its hash value is 001, and in this bucket we store Lisa Smith and its value. In a similar way, all the keys are stored. Now the advantage that this gives us, that every key has a unique hash, so it helps in searching, sorting, and all the other operations performed on a map. Now what this does is that it reduces the time complexity. So in maps where we have a time complexity of log n, in unordered maps we have a time complexity of O1. Now of course this helps in our competitive programming, where we can solve problems related to TLE with this, and but of course the order is changed. Here we had keys in this specific order, but here the order is lost because of hashing. So depends on if you want the order or not. You can use either ordered maps or unordered maps. So now with this introduction, let's get to coding. Now the declaration for an unordered map is same as that of your ordered map, where you have unordered map followed by the data type of the key and the value. Here we would be creating an unordered map called constants, which would be storing a different mathematical constants for us. So we would have a key of type string and a value of type double, and we would also change this to include an unordered map. Okay, so now to insert values there in an unordered map, there are two ways. First is the one that we used in maps, where we use the map name followed by insert. The only difference here is that instead of pair, we call the function make pair and pass values to this function. So suppose we have e, 2.718. So this is one way. The other way is using the map name followed by square brackets, and in this we give our key, suppose pi is equal to 3.14. Now these are two ways to insert values in maps. Okay, now let's insert some more values. After inserting values, let's display those values using a for loop again, as we did in maps. Okay, we have our for loop ready. Now let's build this. We can see that we have all our values displayed here properly, and then one more thing that you can notice here is that we inserted e first, followed by pi, root 2, root 3, and so on, but our order here is different because of the hashing. Another function which is important in unordered maps is called find. So what the find function does is that it looks for a specific key in the unordered map, and if it finds the key, then it returns the iterator pointing to the key, and if it does not find the key, then it returns the last iterator. So if we have find with the specific key in the parenthesis, which here I will take pi, if it returns the end of the unordered maps, which then it means that the key was not found. So here we would be printing that pi was not found. Otherwise pi was found. So let's run this, and here we can say that pi was found. Okay, so the next function that we will be talking about would be the at function, which lets you reference a specific key value pair. So for that, all we need to do is our map name, unordered map name dot at, and in the parenthesis we give the key. So let's say we type log e and then we run it. We can see that the value is 1. The next is the count function, which counts the number of elements with a specific key. Now let's say I write this, then it will count all the values with the key log e. Here of course we have only one element, so the answer would not change and it would be 1. Then now this function count is usually used to check if an unordered list map has a specific key or not. And with this we come to the end of our talk on maps and unordered maps.